Howdy, today on Flippin Science we're looking at fuels and combustion.
Am I only dreaming, or is this burning an eternal flame? Say my name, sun shines through the rain, the whole life so lonely, and then come and ease the pain.
So the ideas in the learning we're going to look at describe the advantages and disadvantages of the use of carbon-based fuels as sources of heat energy compared with their uses of feedstock, and describe the undesirable consequences of incomplete combustion. So a good place to look at for the advantages and disadvantages of using fuels as a source of heat energy rather than feedstock is the textbook. Page 141 to 143, there's lots and lots of detail, it goes into much more detail than I'll go to. But pretty much it sums up as there's advantages and disadvantages to using carbon-based fuels. They're handy because they have a high energy density. That means you've got a lot of energy released per molecule, per mole, per gram, per litre. Because there's lots of bonds in carbon-based fuels. Carbon can make 4 bonds, so it makes lots of long chains and so on, so it's very energy dense. Currently we have large reserves of coal and oil. These are diminishing over time, but as time goes on we're really just using less nice sources of oil, so heading to things like shale oil and sand and tar sand oil. So it's less readily available, but it's still there. And natural gas, which is common in Australia, it's relatively easily extracted and it burns clean. So as long as you've got enough oxygen available, you can get complete combustion. There's disadvantages though. Although we have large reserves, it's not renewable. The Earth isn't making any more oil at the amount of speed that we need it to. It takes millions of years to make oil and gas. When you burn carbon-based fuels, often they have sulfur as an impurity, and that produces sulfur oxides, which leads to acid rain. The combustion products aren't particularly healthy. Carbon monoxide, we'll talk about that later on. Carbon dioxide has global warming impacts, and again we've talked about that before. One of the main things is though you need to compare against using it as a chemical feedstock. And what that means is if we burn all our petrochemicals, what do we use to make things like plastic? So most plastics are made of petrochemicals. If we're burning those to make to release energy to heat us up or make electricity or something like that, then we're not using it to make plastic. But it's not just plastics, it's things like medicines. A lot of medicines are petrochemical based. So there's advantages to using these things as fuels because they have high energy density, easily available and relatively cheap. But if once we burn them, we can't use them again, and we don't really have a replacement for that. So that's what you need to think about there. Alright, so we're going to talk about the combustion of fuels. So when you completely combust a fuel, if it's carbon-based, like an alcohol or a alkane, the only products you get are carbon dioxide and water. So here's a good example, methanol. Methanol is used as a fuel in Formula 1 racing cars. You burn the methanol in oxygen, you get carbon dioxide and water being released. So here's an example equation of that. Other hydrocarbon fuels are butane, so this is in cigarette lighters, so I've got a little cigarette lighter here, that's also a watch, which seems foolhardy to me. And octane, so here's someone burning some petrol. Octane is one of the many components of petrol. So here I've put the combustion equation where I've doubled everything to keep it in whole numbers, but you can also divide these by 2 to get them into their a single here, and then you have the ratio of your main reactant to the other reactants and products. So here we've got octane. So octane, if we did the same thing, that would be C8H18 plus 25 on 2, so 12.5 oxygens goes to 8 carbon dioxides and 9 waters. Now there's 2 types of combustion. There's complete combustion, where all the oxygen required to break up all the carbon-based fuel is supplied, so only products are carbon dioxide and water. And then there's incomplete combustion, where there's just not enough oxygen available, so you don't get carbon dioxide and water being produced. You can get a variety of products from incomplete combustion. One of them is soot, which is particulate carbon, which are pieces of carbon that don't burn, and carbon monoxide is another thing as well. Both of these are harmful in the environment, and we'll talk about why. So like I said, if there's not enough oxygen, then you don't get complete combustion. And if we have a look at our example down here, we've got octane. So octane with 12.5 oxygens goes to some carbon dioxide plus some carbon monoxide plus water. Now, the ratio of carbon monoxide to carbon dioxide and even particulate carbon, it depends on how much oxygen is available. So in this case, we've got 12.5 oxygens available. If there's more, we might get more carbon dioxide. If there's less, we might get more particulate carbon. And you can see in this flame over here, it's incomplete combustion. These complete combustions, you get usually a colourless flame, whereas over here you've got oranges, browns, and you can see a whole heap of black there. That's the particulate carbon that's coming up as soot. A great place to see the consequences of incomplete combustion are in a Bunsen burner. So if you close the hole down the bottom, you're not allowing enough oxygen in to burn with the gas, and that means you get incomplete combustion and you get soot. So it's a very sooty flame, the safety flame. If you open the hole partially, you'll still get a bit of yellow, but you might get some blue coming through. So you're allowing a bit more oxygen, but you might get some carbon monoxide being released. So when we use Bunsen burners, I open up the door on the window so that we can get good airflow through to take away some of these products. Both of these things are undesirable. Carbon and carbon monoxide have health consequences, and we'll talk about that now. Oxygen is carried around your blood in a compound called hemoglobin. Carbon monoxide is really good at binding to the exact same position on hemoglobin, which is the protein down here, as oxygen does. So what happens is the carbon monoxide sticks to the hemoglobin where the oxygen would, and that means you have less and less oxygen travelling around your blood. It also bonds quite strongly, so it makes it very difficult for the oxygen to replace the hemoglobin. So what happens is you are reducing the amount of oxygen carried around your body, your brain shuts down, and then you can die if you breathe in enough carbon monoxide. So you want to avoid breathing in carbon monoxide. Another bad product of incomplete combustion is particulate soot. So this is a piece of soot particle. This would be about 10 microns across, so 10 micrometers across or so. Anything below that size, it gets lodged very, very deep in the lungs, and your body essentially can't get rid of it. It's stuck down deep in the lungs, so it stays there. And that can cause over your lifetime a lot of issues. Soot from diesel, for example, the incomplete combustion of diesel, has been linked with increasing rates of lung cancer in cities. So in cities where you have large trucks which are burning diesel but not completely as they're going past, these small particles get lodged deep in your lungs. Your immune system constantly attacks them, but it can't get rid of them, so the immune system is just going over and over again, and that can lead to cancer in the long term. Unburnt hydrocarbons are another thing that you can think about. So petrol, when you're burning in your car, oftentimes some of the petrol molecules don't get burned and they just go straight back out the tailpipe. So when that happens, that's bad too, because you're not getting any energy from that fuel. You're buying it, it's going into your car. Some of it's being burnt, but not all, and then it passes back out. And that has also other effects in terms of photochemical smog. Peroxyacyl nitrates can be produced, which are nasty things to breathe in, as well as aldehydes from the breakdown of the fuel in the environment. So there's lots of bad products you get from incomplete combustion. So today on Flipping Science, we looked at combustion. That's it for Flipping Science today. See ya.